Okay, so dynamic torque control. So what does it do? And really, before we get into this, I just want to explain to you really what how our all-wheel drive systems work overall. So Toyota's all-wheel drive systems are designed to send power to front and rear axles automatically on a as-needed basis. As stated before, this action requires no driver input. And this is made possible by using an electromagnetic coupler that manages power needed between the front and rear axles, which rely on sensors that are able to detect wheel spin. When wheel spin is detected, a special ECU or electronic control unit applies a brake to the spinning wheel, sending power back to wheels with traction. During normal driving conditions, these systems default back to front-wheel drive to optimize fuel economy. And in the case of this dynamic torque control all-wheel drive, it's very different from what we've seen in past all-wheel drive systems like the active torque control system that you might be familiar with. It is actually currently on the 2020 Sienna. This system sends power flow, 50% power torque to the back of the rear axle when needed. And you can think of the active torque control system as a reactive system. So it has to actually detect wheel spin before it begins working, whereas this new dynamic torque control all-wheel drive system sends a variable, and that's the key word here, variable amount of torque to the rear, and that is anywhere from 10 to 50% torque. And instead of being an active, reactive system, this is a proactive system. So this system does not need to detect wheel spinach to engage itself. It uses factors like throttle input, steering angles, and something we call yaw sensors. And if you have any questions on what yaw sensors are, Mr. Tom Kretschmann will be able to answer these questions at the end. But really, these sensors are able to detect when a driver might need all-wheel drive, and it'll automatically engage it, seeking optimal driving performance. All right. So moving on to the Highlander all-wheel drive system. So, and before we go into it, I just want to say this system is on the Highlander L, the Highlander LE, and the new Highlander XLE, okay? So the Highlander all-wheel drive system works similarly to the dynamic torque control all-wheel drive system in that it also sends a variable amount of torque to the rear wheels, but with one added benefit. This system also offers a driveline disconnect. So the driveline disconnect is made possible by having two ratchet type dog clutches. And if you see here on the screen, there are these ratchet dog clutches here and here located on the driveline. You can think of these dog clutches as keys that lock and unlock the driveline, connecting or disconnecting the front and rear axle. So what's the benefit of a driveline disconnect? Well, it simply decreases fuel consumption by making it to where the driveline is no longer spinning when all-wheel drive is not needed. All right, jumping into electric on-demand all-wheel drive. And this is the all-wheel drive system that you will find on the Highlander Hybrid LE, XLE, Limited, and Platinum, and the RAV4 Hybrid LE, XLE, XSE, and the Hybrid Limited. So electric on-demand all-wheel drive, this hybrid all-wheel drive system is unique in that there is no mechanical link between the front and rear axles. The rear axle is powered by a separate electric motor, and this motor connects to the hybrid battery. In this hybrid all-wheel drive system, the rear axle contains magnets that work as a generator in order to create its own energy and give power to the rear electric motor. So as you can see here, the most obvious difference here is there's no driveline that connects the front and rear axle. Instead, it's the hybrid battery that's giving the rear axle the power it needs to engage itself. And then jumping into Toyota's all-wheel drive E, this system is the one you will find on the Prius all-wheel drive E LE and the XLE. And you might see it seems a little bit similar to what we just saw with the on-demand hybrid all-wheel drive, but the all-wheel drive E system does not use magnets. Instead, this system uses an induction motor, and this induction motor creates its own electromagnetic field. And so the purpose of having this induction motor instead of regular magnets is because magnets are heavy. So by not having them, it reduces vehicle weight and in turn reducing fuel consumption. All right, and then we're gonna jump into dynamic torque vectoring all-wheel drive with driveline disconnect. But before I pass that on over to Tom Kretschmann, I just wanna show you which vehicles have this feature, and that is the new Highlander Limited and the Highlander Platinum, the RAV4 Adventure, the RAV4 Limited, and the RAV4 TRD Off-Road. Okay, so Tom.
All right, thanks, Edgar. Give me 1 second. I'm going to switch my screen here for everyone. Let's share. All right. Can everyone see this screen?
Yep, Tom, you're good.
Okay, good. So just want to break down this newest all-wheel drive system. This first debuted on the RAV4 when this current body style debuted a couple years ago, and we've carried the system into Highlander. So the dynamic torque vectoring with all-wheel drive or with driveline disconnect features several different things that benefits the customer. So the first thing is, and Edgar alluded to this in terms of the other gas-powered Highlanders, they also have this driveline disconnect feature. The driveline disconnect is fully automatic, and it's going to disconnect all-wheel drive when it's not needed, but it's going to disconnect it right up front. And I'll show you an illustration of this in a second. Requires no driver input. It's completely seamless. And of course, by eliminating that drag of spinning some of the driveline components, you're saving on fuel efficiency. The torque vectoring system is going to direct torque away from a slipping wheel to the wheel that actually has grip. And it does it in a manner that helps ensure that the vehicle stays on the driver's intended path. The whole concept behind any of these all-wheel drive systems is to give the driver more confidence in the vehicle. The vehicle doesn't feel like it's slipping. The vehicle is responding to the driver inputs, and that's the whole engineering purpose behind this. So this system enhances confidence on any road condition. So it can be off-road on a trail, or it can be on-road, and in both scenarios you get a benefit with the traction. So this is a layout of the torque vectoring system. This is a similar diagram what Edgar showed you a few minutes ago. So up here you have the engine and transmission, and then you see these dog clutches. And just to clarify what these dog clutches are, they are, like Edgar said, they're kind of like a key to either lock in or disconnect this drive line. They're unlike a regular clutch that you're used to in a manual transmission car. A regular clutch is like a slipper clutch. When you engage it, you let the pedal out slowly. That slips the clutch into full engagement. These dog clutches work differently. They literally lock in like two gears meshing. So once they're either completely disconnected or they're connected, they just lock together. And then you'll see back here on the rear axle in this differential, you're going to see two sets of clutches. And what this does is it allows the power to flow through to the rear axle and then be directed either left or right. So you're either going to power one or the other, or it can vary. You can go 10 to 50% and so on, or you can have it equal on both sides. And the computers will sort out when that's going to be needed. So to explain the driveline disconnect, I want to show this little video illustration. This is showing the vehicle driving along in front wheel drive. The power is being delivered left and right. This drive shaft and all these components are not turning when we're using the driveline disconnect feature. When it's needed, it will lock in. Keep in mind, driveline disconnect does not mean this vehicle can be dinghy towed. I know it's very popular in the Pacific Northwest to dinghy tow small vehicles behind RVs, but you can't do it with any Toyota vehicle currently made. You either have to have it on a dolly or trailered. So check with the owner's manual for the specific vehicle you're wondering about. But when in four-wheel drive, we'll show you how this rear torque vectoring system works briefly, and then I have an additional illustration here in a second. So as the power comes into this rear differential, it's going to deliver the power using these clutches. You'll see this one squeeze, this one will release, and so forth, delivering the power either left or right. Now, the thing to keep in mind about differentials is that, you know, a lot of you are probably saying, what is it? I don't even know what a differential is. We're going on and on about differentials. I don't even know what it is. So let me very briefly explain what a differential is. The differential is a gearbox that's located either here in the rear axle or up front here at the front axle, or even in the middle to deliver power to two directions. The reason we use these gearboxes is because when the vehicle turns a corner, the left and right wheels have to turn at different speeds because the outside wheel is traveling a little bit of a longer path than the inside wheel. The problem with a differential in its inherent design, a basic differential, is that when it delivers power to the path of least resistance, which if you're on dry pavement, generally that's fine, there's no issue. But if you start slipping, the wheel that has slip will continue to slip. You pull out all my stops. Here's my Lego differential, and you can see it turning here. So you can see I have a drive shaft, that's the engine power, and that's delivering the power left and right. But if as you can see, the wheels here, let me even them out. So you'll see the wheels are pretty much turning at the same rate. But if I try to slow, like this wheel here has some traction, it just delivers the power to the wheel that doesn't have traction. Same with the other side. And it's all based on how that gears work. So this is a solution. This is an engineering solution to that problem. And it's the most advanced engineering solution we have to that problem. So why is this so good? Or let me show you in this video here. The real reason it's so good is because most of the time you're driving a RAV4 or a Highlander, you're on road. And what we want to show you here is this scenario here where we're using torque vectoring on the road. What happens is because we can deliver power left and right, look at these arrows. These arrows are going to indicate which wheel is getting more power to it. So if the arrow is longer, you get more power. Think of it this way. If you're pushing a shopping cart along and you're using both hands, the shopping cart goes straight. But if you release one hand and push just with the other, the shopping cart will turn one way. Use the other hand, it'll turn the other way. That's what we're doing with these clutches, is we're almost push steering the car down the road when the computers see that it might be beneficial. There are a lot of roads that are like this in the Pacific Northwest, these turns. And here I'm going to pause it for a second. So what we're showing here is the vehicle that's following this blue line, that's a vehicle with torque vectoring. The torque vectoring system is not only helping the whole system guide the car the way the driver intends, but it can push steer. Think of it this way. If you have a front drive vehicle, you have two wheels up front, and those two wheels are pulling the car along, and it's turning the car. It's a lot of work for those wheels to do. On these mountain roads where you're accelerating up the hill and you're turning, you're asking a lot of those front wheels. So what the computers can see based on throttle input, steering input, yaw rate, and so forth, is it can say, you know what, if I engage the rear wheels a little bit, that'll help. That'll help the fronts do more steering work. And I can also use the push steer effect of torque vectoring to get this vehicle to follow the exact line the driver intended. And that's what we're demonstrating here. Without torque vectoring, the car is going to want to try to push towards the outside of the turn. So that's the benefit on any kind of dry surface. But the other thing is this is a very effective system in situations like we're showing here, where you might have slick spots on the road. The torque vectoring can see if the wheel slips, immediately it can direct torque differently. So it can react. Now, here's another scenario. I want to back this up just slightly to show you the benefit off-road. So here we have a generic Toyota SUV. We'll call it a Highlander RAV4 thing. Anyway, sorry about that. Get back to my video here. And let me get to the off-road section. Here we are. So as it sees a wheel slipping like this, it can immediately direct torque to the other side to give you grip. Now, we have systems in place that do the same thing, but we use the brakes. If it sees a wheel slipping, the wheel starts spinning like this, and then we apply the brake, and eventually it'll get that vehicle going. The difference between torque vectoring and like the active we call it like an electronic limited slip situation, is the torque vectoring can react more quickly and it reacts more smoothly. So that's the benefit on these vehicles, both on and off-road, is that you get good all-terrain capability as well as good on-road confidence. So with that, after I show the disclaimer there, I'm going to stop sharing my screen, and I think, Edgar, you're going to take over here.
Yep, thanks, Tom. I'll share my screen here. All right. So just to let's see here. Just to reiterate here, so the benefits of dynamic torque vectoring all-wheel drive. So as Tom mentioned, automatically switches from two-wheel drive to all-wheel drive as needed, directs torque away from the slipping wheels to wheels that have grip, achieves high off-road performance even on the toughest roads, enhances driver confidence by controlling torque to help ensure the vehicle stays on the driver's intended path. And this technology is a Toyota first, which is big, especially for us. We're very confident that this system is going to be of benefit to not only our customer but to you all that sell these vehicles, and I'm sure this is going to definitely help you all in that endeavor as well. So with that, I just want to show you a few resources that you can use. A lot of this information I actually found on Engage. I posted a link under this Engage icon here. This video is awesome to show you just how some of these systems work. Don't worry about writing the link down. This recording will actually be posted on the sales training section in Dealer Daily under the COVID-19 tab. Also encourage you to use the Toyota app for more training needs here. And before we get into questions and answers, I do want to say we have started a Toyota PDX training team Instagram page. This page we're going to utilize to post as much as we can regarding training and new product. So if you're a salesperson or sales manager, or really anybody at the dealership that wants to stay up to date on our Toyota information, please follow our page and also subscribe to our Toyota Portland Sales Training YouTube channel. We're going to do our best to post as many videos as we can. So hopefully this is a benefit to you all as well. And with that, Stevie D, I want to ask, do we have any questions at all for us to answer here?
Edgar, yes, we do. We have a question. I don't know where it comes from, but can torque be split between the rear wheels at different rates with the all-wheel drive E? I think that's a good question for Tom Kretschmann.
So no, on all-wheel drive E, we're relying on wheel speed sensors to see any kind of slippage. If it detects that a wheel is slipping in the rear, it's going to apply the brake. So the all-wheel drive E is basically, we've eliminated the drive shaft going back to that rear differential. And in replacement of that, we've put an electric motor. It's an induction motor for that system. And that motor then delivers the power to the rear wheels via a standard basic open differential, like that Lego differential I just showed. And so when it sees a wheel slip, it applies the brake, that directs the power to the other side.
Thank you, Tom. We do have another question from Donald. What's the simplest way to explain the difference between all-wheel drive and four-wheel drive to our customers? Donnie from Toyota Vancouver. So
Donnie, the simplest way I would explain it is that on Toyota vehicles, if we've called that system an all-wheel drive system, it is it has the characteristic of running in front-wheel drive when it's not engaged. So it is based on a front-wheel drive platform. Though you can take it off-road and though you can tow with these vehicles, they are not the most rugged of our four-wheel systems that we have. The four-wheel drive systems on Toyota vehicles are distinguished by having a two-speed transfer case. Those are going to be the four brothers, as we call them: Tacoma, Tundra, Sequoia, and Land Cruiser. I'm missing one. There's actually, Forerunner. It's actually five brothers. But anyway, the point I'm making is all of those have two-speed transfer cases. And the low range on that two-speed transfer case is for very rugged off-road use or for very hard pulling, like you're pulling a boat out of water, something like that, or you're pulling your friend out of a ditch because he's driving a competitive brand vehicle, got stuck. That's what we have those vehicles for. So 4x4, 2-speed transfer case, rugged, all-wheel drive, fully automatic, easier to operate, based on a front-wheel drive platform.
Thank you, Tom, for the answer. Great question, Donnie. It may seem simple to us, but some customers need it being explained in layman's terms, and so that's a great question. We're looking for a few more questions. If anybody has any questions you'd like to answer, we have the team and Tom Kretschmer here to answer those. I have a question, Tom, and maybe you can answer this, or the team. Moving forward with all these different platforms, all-wheel drive, hybrid, we're going to see a few more sport utilities down the road. Are we going to see any additional all-wheel drive systems, or do we have it covered right now?
That's a really good question. I think I haven't seen too much in the crystal ball, but I will say this. What I found interesting was how our engineers approached all-wheel drive on Prius, because the all-wheel drive E-system on Prius is slightly different than the all-wheel drive system on our hybrid RAV and hybrid Highlander. The hybrid RAV and hybrid Highlander use a kind of a beefier rear motor and differential setup to give the rear axle more power, because they know that people may tow with those vehicles, and they may also take those vehicles off-road. So those vehicles, like Edgar mentioned, have permanent magnets, and there's some pros and cons to that. The pros are you can regenerate energy when you're braking, and you also, because they're larger, they can produce more power. The all-wheel drive E system uses those inductive magnets, which basically means we have to electrify the magnetic items inside that motor in order to create torque to the wheels. The downside is it can't be used for regenerative braking in the rear. But what's interesting is the way they designed the all-wheel drive E system in the Prius. It was designed to give you on-road traction while not affecting your fuel efficiency hardly at all between a standard Prius and the all-wheel drive version. So I see them working to perfect that technology, because there's a high demand for all-wheel drive vehicles, especially in your neck of the woods, and possibly delivering that into future product. I don't know specific, trust me, you'd think I'm in headquarters and I have access to the crystal ball, but I don't. So I could see them expanding that all-wheel drive E. And it'll be interesting to see if they can adapt this torque vectoring system to some vehicles like Tundra.
Right. Yeah, great insight. Thank you, Tom. Actually, we got a couple more questions here. We have one from Carson. All-wheel drive turns off at what speed, MPH?
Okay. When you're talking about a gas vehicle, gas Highlander, gas RAV, even the Camry and Avalon that are coming up, the gas versions, it goes to the vehicle's top speed. I think on some of those it's limited to like 110 or 1, but the vehicle's top speed is also about the same. So it's within 1 mile an hour top speed. So on a gas variant, it can engage all-wheel drive up to the vehicle's limited top speed. The only vehicles that have limitations with top speed really are the Prius all-wheel drive. The Prius all-wheel drive will disconnect at, I'm trying to remember, I think it's 53 miles an hour. If I'm not remembering properly, it's about 53 on the Prius. So the Prius is the only one that has a speed limited, I'm going to disconnect all-wheel drive at a particular speed, and that's because of efficiency, really. So that's the only one you really have to be concerned with disconnecting.
Thank you, Tom. Carson, we'll get the, I think Tom's close to that number. If you could let us know what dealership you're at, we'll follow up with you and get you the exact cutoff on all-wheel drive on the Prius. It's close.
I think it's 7 to 53, if I'm not mistaken.
Yeah,
So
Yep.
I'm going to come in on that. It's to 43 miles per hour.
Oh, 43. All right. I knew it was a 3. 43, 53, you know, whatever it takes.
And we have another question here, and the question is, I have a 2020 XSE hybrid all-wheel drive RAV4. Why does it hum when I put the vehicle into reverse?
Oh, are we talking about put the vehicle in, it hums? Is this the noise that you hear from the outside? That might be the vehicle proximity notification system. Oh, well, actually, the other thing about hybrid all-wheel drive is that I'm trying to remember now, reverse is always in electric, if I'm not mistaken. You might be hearing the motors actually working instead of the engine running. That might be the reason why. It's one of
Okay.
those two things.
All right. Any other questions out there in dealer land? We'd love to answer those for you.
Does everyone understand the concept of how these vehicles sort out when to apply the torque? I kind of mentioned it very quickly, but I said throttle and steering angle and then yaw rate. Does everyone do we want to spend a minute? Because I can explain that pretty quickly. What do you think, Stevie?
Yeah,
You understand
Tom.
that?
Yeah, I think it's a great thing to send out. Definitely.
All right. Can people see me on the screen holding up a car? My Toyota Terreno 86.
Yep. You're getting
All right.
yeses
My
from
Hot
everybody,
Wheels.
Tom.
All right. Here we go. So when you're driving down the road, you have acceleration, which throws the car back on its rear axle. You have braking, which throws it on its front axle. You also have so the car is watching everything that's going on. And one of the things that it's watching is yaw rate. And yaw rate is the rate that the car is rotating around a turn like this, left or right. So when you're going down the road and say you're going 50 miles an hour and you turn the wheel a certain amount, it sees, okay, you've turned the wheel 5 degrees. And based on that 5-degree turn, it also knows that the car should rotate at a certain rate. At 55 miles an hour with 5-degree turn, the car should rotate that quickly. If the car exceeds that rotation, it means it's oversteering and it will do corrections for that. If it sees it not turning fast enough, it's understeering and it will make corrections for that. The torque vectoring system primarily affects understeer conditions, meaning you've turned the wheel, but the car isn't wanting to turn. And that's when it's going to kick in. So that's about the simplest way I can explain that concept.
Thank you, Tom. Great explanation, great answers. A lot of feedback from everybody, giving you the thumbs up. Any other questions out there in dealer land? Any questions from the team here? All right, we'll wrap it up and we'll send it back to Edgar.
Awesome. Thanks, DVDs. Thank you, Tom Kretschmann here.
Yep.
Well, with that, we're going to conclude our training for today. Please stay tuned for our last seminar, which is going to be next week. Mr. Stevie D is going to be hosting a presentation on safety. And with that, everybody, please stay safe, stay healthy, and thank you all for tuning in and have a great rest of your day.